Welcome to qnawire.
We have a paragraph of information here. I'm going to start by writing it down in probability notation. 30% of the children in this class have grey eyes. So if I were to pick a child at random, the probability they have grey eyes would be 30%, 0.3. All of this is going to be in decimal form because percentages do not play very well with calculations. 50% of these students have blue eyes, so probability our random student has blue eyes is 50%. Probability of a different colour, other, is 20%. These three options partition the sample space. Every child will have one of these three options, and none will have more than one. Now, one day they play a game together. 65% of the grey-eyed students are selected, or children are selected. So probability of being selected, given the student has grey eyes, is 65%. 82% of the blue-eyed students are selected. So selected given blue eyes is 82%. Selected given other is 50%. A child is selected at random. We know they were not in the first game. What's the probability they have blue eyes? So we want the probability of blue eyes given they were not selected. So put prime there. Okay, so I'm going to do another column here. Not selected given each colour. 0.35, 0.18, and 0.5. Because if they weren't selected, they were not selected. Now, when you want to flip conditional probability like this, you use Bayes' theorem. The probability of y given x is equal to x given y multiplied by y divided by x. And we're going to apply that here. So I'm going to need some more space. So the probability of not being selected given blue eyes multiplied by the probability of having blue eyes divided by the probability of not being selected. Okay, we don't have that, but we can find it. There are three ways someone might not be selected. Maybe not selected and they have grey eyes. Or not selected and they have blue eyes. Or not selected and they have a different colour of eyes. That covers every possible way this could happen, since everybody has one of these eye colours, and there's no overlap here because each person has only one of these eye colours. Now, to get the joint probability, we use the numerator here, x given y times y. So this is 0.35 times 0.3, 0.18 times 0.5, 0.5 times 0.2. It's a kind of weighted average. I'm just going to calculate that now. 0.8 times 0.5 plus 0.5 times 0.2 all adds up to 0.295. Now all we have to do is evaluate this. And I get 0.3051 to 4 decimal places. The probability a student has blue eyes, if you know nothing else, is 50%. But if you know they haven't been selected, knowing that most of the blue-eyed students were selected, the probability they have blue eyes drops.